Thank you, Teal. Can everyone see my screen okay? All right. Thanks for the introduction, and thank you for the opportunity to present for the Alaska Climate Action Network. The University of Alaska Fairbanks Troth-Yetta campus is in the traditional homelands of the Lower Tanana Dene. I acknowledge the ancestral and present land stewardship and place-based knowledge of the Alaska Native peoples. Today, I'd like to share a broad overview of wildfire in Alaska within the context of a rapidly changing climate. The presentation is based off of a public outreach handbook published by the Alaska Fire Science Consortium and the International Arctic Research Center. The report was authored by myself and Heather McFarland with significant help from researchers at UAF and especially the interagency wildfire community. This is a fire-specific follow-up to the 2019 outreach publication from the International Arctic Research Center called Alaska's Changing Environment. Please type questions in chat as they arise, and I will try to answer them during section breaks in the presentation. First, I'd like to start by introducing the Alaska Fire Science Consortium. If you've never heard of us, we are a small organization housed at UAF's International Arctic Research Center. We work closely with land managers and researchers to help bridge the gap in boreal and Arctic fire science delivery, outreach, and application. We provide products and services, including seasonal workshops and training, science highlights, proposal support and collaboration, consultation by subject matter experts, and direct support for the Alaska Wildland Fire Coordinating Group. The Alaska Fire Science Consortium, or AFSC, is one of 15 regional consortia supported by the Joint Fire Science Program and is part of a national fire science knowledge exchange network. As part of this network, AFSC works to strengthen connections between fire science research and on-the-ground application. Now that you know a little bit about us, I'd like to jump into Alaska's changing wildfire environment. The landscape of Alaska presents many unique opportunities and challenges. Alaska is the largest state, the lowest population density, the most public land, in complete isolation from the continental United States. Wildfire is a natural process in Alaska that provides complex ecological effects. In the context of a rapidly changing environment, understanding emerging trends in wildfire compared to previous decades can help us better prepare for what wildfire may look like in the coming decades. Alaska needs specific fire management tools to meet its unique needs. Alaska fire managers partner with scientists to improve the scientific basis for management responses to changes in fire and climate conditions. In today's presentation, I will provide a high-level summary of the seasonal phases of fire, wildfire management and trends, wildfire impact, science applications, and preparing for wildfire. There are free copies of the report available. Please email me and you can request them for yourself or even for larger groups. And you can view the publication online in PDF format. The link should be in the chat. And also all of the figures used are packaged and I would be happy to see them reused. So please use them and share broadly. Area burned by wildfire varies tremendously from year to year. Factors such as temperature, drought, and earlier snowmelt contribute to this variation. Most of these fires occur in the interior boreal forest between the Alaska and Brooks mountain ranges. Despite variability from season to season, evidence suggests that wildfire is burning more acres and expanding into new areas of the state. area burned, along with fires that are more frequent, survive over winter, or reburn the same location after just a few years, are consistent with the predicted effects of climate change. This has statewide implications, including increased fire risk for people, property, and resources. Here's a more detailed version of the previous graph. Here, the orange and pink shades represent fire seasons that are above normal. As you can see, above normal fire years are becoming much more common, as in more acres are being burned than normal. The past 20 years have experienced a clear shift towards more frequent large fire seasons. Although years with relatively few burned acres are still common, this variability is due to many factors, climate, and lightning occurrence. Even when it is a relatively small fire year in Alaska, looking more broadly at other Arctic and boreal regions gives a clear impression that more land is burning as the Arctic rapidly warms. I'd like to take a quick look beyond Alaska at the most recent circumpolar trends in fire. This image comes from the NOAA Arctic Report Card, Special Wildfire Edition, Wildland Fire in High Northern Latitudes. More central dotted line here represents the Arctic Circle. As you can see, since 2001, there has been quite a bit of fire activity in the far, far north. This is a sign of fire spreading from its historic boreal ranges into the deep Arctic. Although 2020 was one of the wettest Alaskan summers on record, it was actually the largest fire year in the far north at a circumpolar scale. You can see this illustrated by the graphic of fire detection within the Arctic Circle here. The main driver of the 2020 fire year was fires in Sakha, Siberia, many of which reignited from overwintering fires from previous years. With that quick global perspective, let's focus back in on Alaska and look specifically at the seasonality of fire in Alaska. These seasonal phases of fire have been widely used by the management communities for over 40 years to describe fire season. The Alaska fire season, particularly in the interior region of the state, can be explained by 4 phases. Fire season begins in late April and early May, typically before full green up when below ground soil is still frozen. The most readily available fuels are dead grasses and surface litter. With these limited fuels, wind is the key driver of fire activity. Fire can spread and grow rapidly, but usually with low severity because it cannot burn deep into the moist and frozen duff. These phases of fire are reviewed first to help give context and better understand emerging trends in wildfire, which are examined later. Alaska snowpack now develops a week later in autumn and melts nearly 2 weeks earlier in the spring compared to the late 1990s. This trend is pushing the fire season earlier, as well as later into the year. Early fire season is often the result of human-caused ignitions when outdoor recreation activities and debris burning lead to unintentional fire starts. These preventable fires are usually close to communities and receive aggressive suppression response, so typically they do not get very large. From this National Interagency Fire Center dataset, we can see that more fires are started by humans than lightning in most years. But these close to home fires are usually typically put out and the highest priority for suppression. Although the number of human and lightning ignitions are comparable, lightning ignitions burn far more acres than human-caused fires each year. Lightning ignited fires are often in areas of limited suppression and are more difficult to reach locations. In most years, and all years with substantial fire seasons, the majority of acres burned are caused by lightning ignitions. These fires are often in remote location where managers can allow fires to serve their ecological role without directly impacting human life or property. On average, nearly 60,000 lightning strikes occur in the interior Alaska each summer. This graph on the right here is lightning strike frequency by region. As you can see, interior Alaska by far has the most lightning strikes. Although lightning data from before 1999 are limited due to sparse sensor coverage, modeling methods reveal long-term lightning trends. Over the past 30 years, June and July lightning activity has increased by about 17%. Increase in temperature and precipitation are associated with lightning frequency, which we are definitely seeing. Lightning is most common at the end of the wind-driven phase and in the middle of the duff-driven phase at the end of July, end of June, and most of July. Here, we are quickly approaching peak fire season, which is driven by long, warm days around solstice. This quickly dries out subsurface fuels known as duff that can easily be ignited by lightning. So what is duff? Duff is a key differentiating characteristic of fire in boreal forests. Just below the ground surface, there are slowly decomposing organic materials mixed with soils that can become very dry and spread fires across long distances. Fire activity may greatly increase in June as long sunny days quickly dry duff fuels. Fires during this period are characterized by sudden growth that are related to hot sunny days and can produce high flammability even though the vegetation may still be green. These peak season fires can quickly become uncontrollable. Recently, in the media, overwintering fires or holdover fires have received a lot of attention. These are fires that smolder underground in the duff and can reignite in the future, sometimes even after an entire winter. Here is an aerial overview of an overwintering fire in Alaska. At labels A, you can see smoldering smoke rising from the duff. Interestingly, at label B, you see a lot of fallen trees that are still very green. This is a sign that the roots have been burned by underground duff fires to the point where the trees fall over. Although these overwintering fires are more frequent and have received a lot of attention lately, even being called zombie fires, they're not a new occurrence. One of the most notorious historical examples of an overwintering fire occurred back in 1941 and 1942 in the Tanana Flats. In 1941, steam engines ran the Alaska Railroad we know today and had to dump their ash pans frequently. In fact, they had fire guards, college students mostly, hired to ride the trains and watch for fire starts and extinguish them. Agency personnel in Alaska think we are seeing more of these holdover fires as the summers get longer, hotter, and drier. This creates better conditions for fires to burn deep into the mossy forest floor, where they are protected from rain and snow during the winter. For example, in 3 different areas of Alaska, including Ferris, Matsu, and Kenai, all spawned holdover fires in early 2020. You can read more about these fires described by AFSC subject matter expert Randy Jant in a recent Nature article, Overwintering Fires in Boreal Forests, or for some lighter reading, check out our fire science blog, AK Fire Science Highlights, and read The Zombie Fires of 1942. Okay, let's go back to the seasonal phases of fire and look at some of the climatic conditions that drive fire throughout the duff-driven phase and into the drought-driven phase towards the end of June through August. Alaska is getting hotter fast. Summer temperatures across Alaska have been increasing since 1970. A typical summer nowadays is close to what the warmest summers were prior to the 1970s. When comparing the average June to August temperatures over the last 95 years, 9 of the 10 warmest summers here occurred in the past 20 years, whereas the 10 coldest summers all occurred before 1975. Of particular concern are extreme weather days. The number of days that reach 77 Fahrenheit per year has increased substantially since the 20th century and are predicted to become much more frequent in the future. Very hot weather like this can result in days or even weeks where fire may be impossible to suppress and can grow rapidly. We can measure the flammability of fuels with a measure called the buildup index. In this graphic, you can see across the globe at high latitudes, there is a tremendous increase in flammability of fuels from 1979 to 2019, with some extreme hotspots occurring north of Fairbanks in the Yukon Flats right here. As we move into July, if temperatures remain high and precipitation low, drought may extend and expand the fire season, as we have especially seen in recent years. Let's take a look at precipitation. There's a great deal of annual variability in precipitation. However, in the last 20 years, we have seen significantly more rainfall in the interior, sometimes as much as 40% more than normal. Research indicates that precipitation would have to increase by about 7 to 10% in intensity per degree of temperature increase to offset the increased fuel drying due to warmer temperatures. So even though we are getting more rain, it may not be enough to keep up with rising temperatures. Precipitation has been increasing with the regional variability of Alaska, as you can see here. As precipitation increases, so does lightning. Based on this normalized data from a 2020 study from UAF researchers, we are seeing significant increase in lightning strikes in many regions of the state. So even though we are getting more precipitation increase combined with more frequent lightning may be contributing to an increase in fire occurrence. Precipitation matters, especially for late season fire events. Let's look at a specific fire, the McKinley wildfire that occurred north of Wasilla. 2019 had the lowest ever recorded precipitation for the region. This incredibly devastating fire occurred in the second half of August, well after a typical peak fire season. Let's take one last look at the seasonal phases of fire in Alaska and consider how the season closes towards the end of August. Cooler nighttime temperatures normally slow fire activity. This is known as the diurnal effect. However, daily low temperatures are increasing. Alaska now experiences many more warm nights compared to the early part of the 20th century. This is especially true for interior communities like Fairbanks. The 5 summers with the warmest nights here all occurred in the past 20 years, whereas the 5 summers with the coldest nights occurred before 1950. Fire season in Alaska is typically pushed to a close by shorter days with lower solar radiation. But as nighttime temperatures drop and relative humidity increases, fire has difficulty spreading. The past 2 decades, however, have included notable late season fire events related to relatively high temperatures and low precipitation in August, such as the McKinley wildfire and the Anahtuvik River fire. Alaska's wildfire season is getting longer. Over the last 40 years, the first large fire of the season starts earlier, and the last large fire of the season starts later. Since 2006, Alaska's fire season has started on April 1st, a month earlier than before. This reduces accidental ignitions by requiring permits in order to burn debris and allows agencies to begin training personnel and allocating resources earlier. In busy fire seasons, such as 2019, the official fire season may extend well into the fall. Now that we have a better understanding of the seasonality of fires in Alaska, we can better understand what is driving the increase in fire size in Alaska. But before we look at the emerging patterns, let's take a break and consider how wildfire is managed in Alaska. But even before that, now is a great chance for anyone to ask questions.
And just a quick reminder, if you're muted there, as we all are, go ahead and put your question in the chat if you have any questions. And I know there's quite a few links in the chat there as well to follow along, but anyone with a question, please do feel free to put it in the chat.
Great. Thanks, Mike. Yeah, there'll be more opportunities to answer questions throughout the presentation, so don't hesitate to just put them in the chat as they arise. So let's take a quick look at wildfire management in Alaska. 3 wildland fire protection agencies are responsible for fire suppression across the entire 375 million acres of Alaska. The BLM Alaska Fire Service, the Alaska Division of Forestry, and the U.S. Forest Service have primary authority to organize fire suppression operations within their regions. The protecting agencies work together under the Alaska Master Cooperative Wildfire Management and Stafford Act Agreement to coordinate wildland fire management efforts efficiently. The interagency fire management in Alaska is remarkable. Alaska's fire protection strategy is determined by the Alaska Interagency Fire Management Plan. The state is divided into 4 categories of protection: critical, full, modified, and limited. These management zones are determined by landowner and are reevaluated annually. Managers prioritize their initial response to new fires based on these zones and the firefighting resources currently available. As you can see, the most critical areas of protection are around communities. The majority of the state is categorized as areas of limited suppression, where wildfire can promote ecological benefit by being allowed to burn freely. Surveillance is used to ensure adjacent areas of value are not threatened. Wildfire in Alaska is unlike anywhere else in the United States. The ability to allow fire to fulfill its natural role in remote areas affords important ecological benefits and limits the buildup of fuels. I completed my master's thesis studying wildfire in California, and the policy of total fire suppression throughout the state in the early 20th century without a doubt created a problematic wildland-urban interface due to giant fuel loading. Village-based firefighters are an important part of management. Alaska has long relied on seasonal wildland firefighters from rural communities. During the 2020 season, the Alaska Fire Service awarded 3 contracts for Type 2 wildland firefighting hand crews based in rural Alaska villages. These crews offer new opportunities and more stable employment for village-based crews since they can work outside of fire suppression on projects like fuel reductions. And when wildfire activity is hot in the lower 48, these crews can be assigned to as needed to the lower 48. Okay, that wraps up the brief management section. And now I see that there's 2 questions in the chat, so we can take a look at these from Jing Q Mao. I hope I pronounced that right. Their question is peat fire common in Alaska? I'd say yes, it is quite common. Does anyone else want to jump in that might know a little bit more about peat fire?
Zeb, this is Allison. It's kind of a continuum, right? From duff to true peat. Peat is really deep duff that is the people who are experts on peat really say that we don't have a lot of true peat in Alaska. I can put a reference into the chat that looks at global peat extent. They would say we don't have a lot of the true peat that you would see in Canada in the more sort of boggy areas. But certainly a huge amount of the carbon that is being going up in fire in Alaska is duff. Is that, and there's kind of a continuum from duff to peat. Is that helpful at all?
Great, thanks, Allison. Yeah, I was kind of just lumping peat with duff as maybe it's more separated out in other areas like Canada. So yeah, it's a fine line between what constitutes one and the other.
Exactly. It really depends. The peat experts would say we don't have a lot of peat in Alaska.
But it can burn, right?
Yeah, absolutely.
Great. And then there's two more questions. Let's start with the other duff question first. So from Seal, we have, how do these correlate with peatlands and permafrost distribution? Are they emitting greenhouse gases? So great question. Yeah, duff is definitely associated with permafrost distribution. It acts as an insulating layer that keeps the permafrost from thawing. And so as the duff burns, it actually exposes the lower lying permafrost, and this greatly contributes to greenhouse gases. And there's a short section on this later in the presentation, so we'll hear a bit more about that. And then from Bill Whitty, we have, are coal fires starts becoming more or less of an issue? And I don't know too much about this. I know the researchers at the Universiteit Amsterdam are investigating this, and I have heard that it is an issue, and I think it is still an issue, but I don't know if it's changing too much in scope. Do you know anything about that, Allison, or others?
And my impression is, and there are a couple agency professionals on, Tim Mowry's on, and he may be able to speak to this also. But my impression is that the coal fire starts are pretty stable in Alaska. People are aware of where they are, and they seem to just come back every year. That's usually fire number one every year, is the Windfall Mountain coal seam. So I think they're pretty steady. But if Tim has anything to add, or anyone else, feel free.
Yeah, Allison, this is Tim Mowry. Yeah, I think you hit the nail on the head. They are, sort of consistent. We see them almost every year. This year we've had a couple of coal seam fires, and they tend to pop up in the same places, each year down near the Healy coal mine area, the Windfall Mountain. I think the Windfall Mountain is actually shale, and or oil shale and not coal.
Right.
But we just had one pop up the other day down in the Sutton area in Jonesville, another coal mining area. So they're, and you see them in the same places year after year. And you're right, they do pop up usually when we get our first warm, dry weather. They'll find some surface fuels and just burn grass, and don't typically present much of a threat, but because they're in areas that burn regularly because of these fires. But so I wouldn't say they're increasing. I'd just say they're pretty stagnant.
Thanks, Tim.
Great. Yeah, thank you, Tim, and thank you for the questions. That helps with the pacing for this presentation. Okay, now let's revisit emerging statewide trends in wildfire. Let's take a quick look at this animation that compares total acres burned across 3 20-year time periods, starting with the earliest. So as you can see, from 2001 to 2020, wildfire in Alaska burned 31.5 million acres. This is over 2.5 times more acres burned than during the previous 2 decades. Fewer places in interior Alaska are untouched by wildfire. Fires occur in Alaska predominantly between the Alaska and Brooks Range, where warm summers, low precipitation, frequent lightning, and black spruce-dominated ecosystems contribute to frequent and large fire. However, we are seeing trends of fire moving outside of this zone into the tundra and coastal regions more frequently. For example, the Anna River of 2007. This fire doubled the total area burned of Alaska's North Slope since the 1960s. It consumed more than 250,000 acres. Notably, the fire was most active in September. Increased fire activity in the far north is of special interest because of carbon stored in permafrost. Frozen permafrost holds an estimated 1,400 gigatons of carbon. This amount of carbon is greater than is what is already in the atmosphere today. Wildfires release this stored carbon to the atmosphere by removing the duff and soil layers that insulate permafrost, accelerating its thaw. Thawed permafrost can cause surface water to drain, resulting in even drier and more flammable duff. As permafrost thaws, it releases more methane and carbon dioxide into the atmosphere, setting up an amplifying feedback to climate warming. One driver of larger fires in the tundra may be increased vegetation growth. Satellite data estimates greenness by measuring light reflected by plants. In the tundra, high measures of greening are associated with increased above ground vegetation, which means potentially more fuel available for fire. Since 1981, the North Slope tundra has significantly greened. "2019 was a remarkable fire year. The Swan Lake fire burned during an unusual lightning storm during very hot and dry conditions. This fire shattered the previous record for suppression cost and cost an estimated $49 million. This deep burning fire even ignited 2 separate fires in 2020 through overwintering fire. The 21st century has had incredibly large fires. The 2004 was one of the largest fires ever in the United States. It burned about 1 million acres and was part of a record-breaking 6.6 million acre burn year in 2004. This fire year is very memorable for me, as I am sure it is for many of you. As a teenager, my main summer interests were playing soccer and online games. While it was so smoky, the internet literally didn't work for weeks, and most of the soccer season was canceled. Okay, let's visualize area burned by decade in another way. Compare the total acres burned per decade to the total area of the state. The red circles show the proportion of Alaska that burned each decade. 2001 to 2010 marked the largest decade of fire on record, with nearly 20 million acres burned, amounting to over 5% of the total area of Alaska burned in a 10-year period. Without a doubt, 5% of the total state burned in 10 years is a lot. But let's zoom in to a particularly fire-prone region, the Yukon Flats National Wildlife Refuge. In the past 60 years, wildfire burned over 8 million acres and touched 64% of the refuge at least once. Wetlands along the Yukon River were the least affected by fire. In addition to increased area burned, reburn fires in Alaska are happening more frequently, possibly indicating a shift to shorter fire return interval. Fire suppression personnel may no longer be able to rely on recently burned areas as effective barriers to new fire growth as they have in the past. Since 1980, over 1,500 fires burned in areas that had already burned during the previous 20 years. The acres reburned annually by these reburn fires significantly increased in the early 2000s, as illustrated in the graph. Let's take a quick look at the Yukon Flats again for a finer scale examination of reburns. Here, the orange and red shades represent areas that have burned at least twice within 20 years since 1980. Since 1980, 29 fires burned in the Yukon that had already burned in the last 20 years. Some areas may have burned up to 4 times. With more wildfires, black spruce forests are expected to shift to grasslands or other deciduous forests like aspen and birch. New research shows that deciduous forests can store up to 5 times more carbon dioxide from the atmosphere than black spruce forests. This may partially offset the carbon released by wildfires in the boreal forest. So a reburn fire occurs when a fire impacts the exact same spot as previously burned. Another measure of fire frequency is the fire return interval, and this is the time between fires within a relatively small geographic area, but not necessarily the exact same spot. One way to approximate the fire return interval is to compare how the percentage of a region burned changes over time, as shown in this graphic. Here we can see the fire return interval varies regionally. Wildfire occurs more frequently in recent decades in central and eastern interior, as well as parts of western Alaska where fire has been less common. However, on the Seward Peninsula, the fire frequency is decreasing, and this may be related to more active fire suppression efforts compared to the 40s and 60s. Okay, that wraps up the section of emerging wildfire trends, and next we'll look at the impacts of wildfire. But first we have a question from Seal. Like California, does Alaska have indigenous informed fire mitigation possibilities? If so, are efforts underway to scale up as part of the Biden climate change efforts? So this is definitely an area of active development, and I'm not sure how much indigenous informed fire mitigation is used currently, but there have been talks to try to get it more active in the wildland fire community. For example, in April, there was a wildfire management workshop at the Yukon Flats, and community members spoke about the traditional ways of managing fire and kind of some of the difficulties with the new fire management requirements. Maybe Allison, you have something to add to that?
Yeah, there's been a little research on this. There doesn't seem to have been a large amount of indigenous use of fire in Alaska, although I think some use by the Gwich'in people. And so the idea of returning to practices of the past, there's not that much evidence that there was that much use of fire in the past. I'm going to put a link to a study about that in the chat. But there certainly is interest in taking new approaches within the indigenous communities in the state, as Zav was saying. And then Steele's got another question about transitions to deciduous forest. And Randy wrote a great recent research brief on that I'll put a link to that in the chat as well.
Yeah, that would be great. And that piece of info comes from Michelle Mack's latest paper.
Yeah, exactly.
Okay, great. Thanks for the questions. Let's move on to the next question quickly. The next section. The impacts of wildfire on people and wildlife are complex. Some effects such as infrastructure damage, loss of life and injury, fire suppression costs, and health problems related to smoke are trackable. Other effects such as habitat change, impacts to hunting and fishing, and public anxiety are more difficult to document. Alaskans are particularly vulnerable, with an estimated 80% of the population living in areas at risk of wildfire. One such example of living in the wildland-urban interface is the McKinley wildfire. On the left here on this map, you can see the orange fire perimeter, which nearly follows the Parks Highway, which happens to be where pretty much all of the structures of the community are located. So this was a true example of a fire right in the wildland urban interface, and the results were devastating. It was possible to measure some of the effects, such as the structures lost, the cost of suppression, the acres burned, but there are other less tangible effects, such as the mental health of the community and recovery. One of the most far-reaching wildfire impacts is smoke. As the frequency of large fires season has increased, so has the number of smoky days, posing a significant health hazard. Wildfire smoke is very hazardous because it contains particles small enough to travel deep into the lungs and bloodstream. This can cause serious lung and heart problems. During active wildfire season, smoke particulates are the dominant source of airborne particles in interior Alaska. Even beyond public health, smoke can limit visibility to the point where air travel is not possible, and this disproportionately affects rural communities that are only serviced by plane. The Alaska Department of Environmental Conservation helps manage smoke-related health risks by providing air quality advisories, regional air quality forecasts, and recommendations for safety precautions and activity levels. This graphic depicts days with less than 6 miles of visibility as reported by the airport. Prior to 2004, Fairbanks had only one summer, 1957, with more than 3 weeks of significant smoke. Since 2004, prolonged smoke episodes have occurred 5 times, including twice since 2014. Smoke is a less frequent problem in Anchorage, but 2019 was by far the smokiest summer. Fish and wildlife did not get much representation in this report. The upcoming publication, Yukon Flats Changing Environment, has some great information on wildlife change, and I recommend looking for it when it is released shortly later this year. One of the reasons we did not go into depth about wildlife-wildfire interactions is that they are incredibly complex. Many wildlife species depend on wildfire to maintain habitat diversity. Impacts to fish and wildlife depend on the species, the time of year, location, vegetation burned, and the severity and extent of the fire. For example, in summer, moose can benefit from the shade and predator protection of birch and aspen that grow after high severity fire. And in winter, highly desirable willow is often available for foraging after low severity fire. Another example, while wintering caribou avoid burns over lichen, burns along migration routes can sometimes benefit caribou. Wildfires that reduce shade over rivers can cause water temperatures to rise, which can impact fish, aquatic plants, and insects. These are just a few examples of the complex relationships between fire and wildlife. Wildfire also has complex interactions with pests and disease. In 2019, the U.S. Forest Service surveyed 25 million acres of Alaska forests, finding over 1 million acres of damage from insects, disease, declines, and other factors. Forest health surveys mapped 140,000 acres of dead or dying spruce in 2019 related to bark beetle. This is not shown on the graph. This is down considerably from the 600,000 acres recorded in 2018 and the 400,000 acres recorded in 2017. However, this decrease in acreage is likely due to fewer live trees remaining. The outbreak is still going on and expanding nearly in all directions from previously affected forests. Spruce beetles are native to Alaska. When in low numbers, they prefer old, slow-growing or injured trees. but during outbreaks, they will infest trees as small as 6 inches in diameter. Surprisingly, dead spruce are not more flammable than live spruce, but the accumulation of dead trees and limbs on the ground can result in large woody fuel loads. As trees died from a beetle outbreak on the Kenai Peninsula, grasses expanded into formerly forested areas, forming dense mats of dry grass which can rapidly carry surface fires. Finally, don't forget that fire scars make for excellent morel foraging. But make sure to stay safe from potential fire and post-fire hazards such as fragile standing trees. Okay, that wraps up the impact section. Now I'll briefly speak about science and management using remote sensing and fuel breaks as 2 examples. Alaska fire managers partner with scientists to improve the scientific basis for management responses to changes in fire conditions. Remote sensing is especially important in Alaska with tremendous amounts of remote land. Satellite fire detection has proven to be an enormous asset in quickly detecting fire ignitions. VIIRS is a polar orbiting satellite that has coarse resolution imagery but has high passover frequency, resulting in valuable fire detection capability. Researchers work with managers to build tools that will help with wildfire management. One such example is an in-development tool from the EPSCoR boreal fires team that uses the VIIRS sensor to provide low and high intensity near real-time fire detections. Here is an example of fire detections produced from Shovel Creek. These detections have direct application to spotting residual fire hazards which can help with resource prioritization. Note the large variability in frequency of detections, which is largely tied to high temperatures and wind. Another example of a remote sensing tool with fire management application is this recently released daily snow cover extent mapping product. This satellite multi-sensor can differentiate between snow, ice, water, and snow-free ground with high levels of accuracy. If you look at this animation, you can see the different pace at which snow is melting year by year. Snow-free dates have large implications for the start of fire season. Okay, on to fuel breaks. One of the best ways to protect Alaska communities from wildfire is by creating fuel breaks between populated areas and wildlands. This UAV footage from fuel break. The break proved to be a great tactical asset in protecting the surrounding community. Evidence from a cooperative project led by UAF shows that fuel breaks can provide an incredibly cost-effective tool for fire suppression. For example, when fuel breaks were tested with the Funny River, Card Street, and Nenana Ridge fires, treated areas had less intense surface fires. Shaded fuel breaks in boreal black spruce forests may reduce fire potential for over 14 years by reducing canopy density and ladder fuels. A UAF study showed that when these fuel treatments are present on public land, nearby homeowners are more willing to spend time and money on improving their own defensible space. Prescribed fire, a form of fuel break, are an important wildfire management strategy. One study found that every dollar in a fuel break equated to 165 saved in protected structures. Along the Kenai National Wildlife Refuge, breaks have helped firefighters protect nearby communities from multiple fires in recent years. Okay, here's the last section, preparing for wildfire. Alaska's changing wildfire environment has recommendations and resources for wildfire preparedness. Key resources are initiatives such as FireWise, Community Wildfire Protection Plans, and Ready, Set, Go. There are many ways to prepare for wildfire, and to take action to help prepare your community for wildfire. If you want detailed tips and resources for preparing for wildfire as a homeowner, please check out another AFSC product, McKinley Fire Lessons Learned. This work, led by Jen Schmidt from the University of Anchorage, is based off of extensive interviews with residents of the McKinley area and Wildfire Agency. Jen also has an amazing video with interviews of the residents that is available and will be linked. One section of the publication covers defensible space, something everyone living in the wildland-urban interface should take very seriously. Here's a picture of a property that was easy to defend and not lost in McKinley wildfire. Note that there is almost no low-to-the-ground vegetation and very limited trees close to structures. You can compare this with a picture of a property that did not have defensible space and was lost. Here you can see there's a lot of low ground vegetation which can spread to the tall trees, which were also very close to the property. This type of scenario can make it very risky for fire crews to operate. With that, I'd like to wrap it up with a summary of a few key messages. Alaska's rapidly changing climate profoundly impacts the state's ecosystems and fire regimes. Most importantly, recognize that wildfire is a natural process that provides ecological benefits, and we need to respect wildfire and take action to protect ourselves and our communities from the dangers of wildfire. And finally, be aware that fire in Alaska is intensifying as the climate continues to rapidly warm. Thank you for the opportunity to share this information with you. I know there's just a couple minutes left, and I'll take questions or we can wrap it up. Thank you.
Thank you so much, Zab. I don't see any questions in the chat right now, but that was fantastic information. Very, very important to know. Let's see. We did want to make sure we put a plug in for akclimateactionnetwork.org. This presentation will be posted within 1 to 2 days, along with the similar presentations from the last 2 series that we did. And again, we'll be taking a break over the summer, but we'll be back in the fall with some more webinar content and from some great speakers. Seal, did you have any outgoing words here at the end?
I just want to joined us, and stay in touch. You can go to the AKA Climate Action Facebook group is where we're most active in making sure that you stay up to date on our activities and our next webinars. So hope to see you there if you're not there already. So that's it, and thanks a lot, everybody.
All right, thank you all, and thank you again, Zab, and in the chat, lots of compliments on the presentation. Great job.
Thank you. It was fun. I appreciate the opportunity.
Yeah, thank you very much for all those links, Allison. They're really going to be helpful. And maybe what we'll do is post a blog or something on our website too that people can still access.
Yeah, I think that's a great idea. Yeah, put them up with the recording if you can.
Mm-hmm.
Yeah.
Yeah.
Great.
Yeah, we may be getting back to you guys with more questions.
Sure, absolutely. That's what we're here for. Thank you very much for the opportunity.
You're very welcome. Thank you.
Have a good rest of your day.
Okay, you too. Have a good summer, everybody. See you next fall.
Bye.